All right, now let's talk about rational versus irrational numbers. Okay, irrational numbers have the following characteristics. Okay, it's anything with pi in the answer. Okay, anything with ugly square roots. Okay, essentially, by definition, an irrational number is a non-terminating decimal, which pi is 3.14159 ... That goes on for forever. Okay, it's non-terminating. It's also non-repeating. Right, so 1/3, for example, 1/3 is 0.3 repeating. While that does not terminate, it doesn't have an end, it does repeat. So 1/3 would still be considered a rational number. So non-terminating, non-repeating. Okay, for example, the square root of 3, right? That's not a perfect square. If you were to check that, the square root of 3 is 1.732050808, and we've just run out of room on our screen to see any more of the decimals. But it's not repeating, it's not terminating, so that would be considered an irrational number. Okay, rational numbers are whole numbers, positive or negative, or they're fractions. Okay, they can be repeating decimals, and they have to be terminating if they're not repeating. Okay, so for example, right, 2/3, 1/2, anything that is a fraction, okay, is going to be considered a rational number. Anything that's a whole number, 5, 10, -10. Okay, or even, well, that's a terminating decimal, right? 0.5, that has an end. This one does not have an end. It does repeat, though. Therefore, it is still considered a rational number. Okay, then we have operations with rational number. If you were to add a rational number to a rational number, you would create another rational number. If you were to add a rational number to an irrational number, for example, like 3 plus rad 3, right? That's going to create an irrational sum. An irrational plus an irrational number. This could go either case. It could end up being rational or irrational. For example, negative rad 3 plus rad 3 equals 0. Well, when you add those irrational numbers together, you get 0, which is considered rational. But if you did rad 3 plus rad 3, that would be 2 rad 3, which is an irrational number again. Right? So we have a case where it becomes rational. I can think of a case where it's still irrational. Right? So that could fall under either category. Okay, a rational number times a rational number will always remain rational. A rational number times an irrational number will become irrational. Okay, if it's a non-zero. And last but not least, an irrational times an irrational. This could fall under either category. It could become a rational number or an irrational number. For example, rad 3 times rad 3, well, those are both irrational, but that equals rad 9, which rad 9 is equal to 3, right? So here's a case where it became rational. All right, but if I change this to rad 3 times rad 2, right, those are both irrational, giving you rad 6, which you can't simplify any further. That is irrational. So we have two different cases, okay, where we ended up getting a rational scenario and an irrational scenario. Okay, next let's talk about accuracy and precision. Okay, accuracy. This is when the estimation is, estimating is when you round at the beginning of the problem. Approximation is when you round at the end of the problem. Right, and then obviously exact accurate mean no rounding occurred. Right, you can estimate how many people are coming to your party. Maybe you estimate 10, right? Estimation occurs before the situation happens. Okay, approximation, and maybe you want to take 1/3 and approximate it. Okay, 1/3 is approximately 0.3. Okay, I rounded. Technically, 1/3 is 0.333333333. So if I round it to 1 decimal place, okay, I can indicate that with my approximation sign. All right, precision. Okay, precision has to do with the following. The more decimal places, the more precise your answer is. Right, the more you round, the less precise your answer is. Okay, rounding to the nearest whole number means there's no decimal. Rounding to the nearest 10th means you're doing 1 digit after the decimal. Rounding to the nearest 100th would be 2 decimal places. And to the nearest thousandths would be 3 decimals. So for example, 5.236. If I wanted to round that to no decimal place, that would be 5. 1 decimal place, or the tenths, would be 5.2. 2 decimal places. Okay, well, if you want to round it to 2 decimal places, the 3rd decimal place is going to make that bump up. So that's 5.24. And 3 decimal places would actually be exact. There'd be no rounding based on the number I gave you. And that kind of concludes rounding and precision.